fifth grade scientists, I'm back. All right, so we just talked about, and right now we're talking about the physical properties of matter. So this week we've talked about density, right? The ability for something to be less dense or more dense than water. We've talked about water, how matter can come in 3 states, solid, liquid, and gas. And water just happens to be one of those things that can come in all 3 states. Well, now Miss Guerra is having a problem. I really, really like hot green tea. I love it. It's so good for me. It's good for my eyes. I love it. But I'm having a problem. I need to keep my hot tea hot. I want it to be hot. I don't want it to get cold. So I am looking for some kind of container that helps keep my hot tea hot in the morning. Can you help me? I hope so. Now, what that's called is the physical property of being an insulator of thermal energy. So an insulator is something that can trap heat in or keep heat from coming in, and thermal energy is heat, right? So I'm trying to figure out what is the best material for thermal energy. So my question is, which material is going to be the best insulator? So I want you to, I'm going to go ahead and look at these tools really quickly. I have glass, I have plastic, I have paper, styrofoam, ceramic, and a metal cup. Now notice they are kind of different sizes, but I tried to get sizes that were just about the same. So I wanted a cup that's just about the same size. I'm using a thermometer. Now, one thing I also need to make sure is I'm using the same amount of water. So I'm going to use a graduated cylinder to measure my water amount, because it wouldn't be a good test if I only put 50 milliliters in one cup and 150 milliliters in another cup, right? That's going to be a different test. I want to make sure that they all have the same amount of water. I'm also going to need to use a timer, because I'm going to be timing how long or what happens, what the temperature is after every 2 minutes. So this is what I want you to do. I want you to pause, and I want you to think about, have a discussion with your class. Which material do you think is going to be the best insulator of thermal energy, and why? So come up with a hypothesis, which is an educated guess, as to why you think which one of these materials would be the best insulator, is going to hold in the most heat. Okay, so I went ahead and poured in my very, very hot water, and they all have the same amount of hot water in them. Now, you're also going to want to make sure that you are collecting your data. So I created my data chart here. And I want you guys to know that I started my beginning time, it was at 95 degrees Celsius, okay? So they are all starting at 95 degrees Celsius. And now I'll see you right back here in 2 minutes, and we're gonna see what differences we see. Okay, so it's been 2 minutes, guys. I'm gonna go ahead and read. So right there I see between 90 and 100, that's 95 degrees. About 80 degrees. 92, 4, 90, oh that's, okay, increment, so 93. About 72. 74 and 65. Okay, let's make sure we record those. We had 95, 78, 92, 70, 74, and 64. I want to make sure that I put degrees Celsius next to each one of these. All right, see you back here in a few. Okay, I waited 2 more minutes, so now it's been 4 minutes. And these were the temperatures. So styrofoam was 89 degrees Celsius. Paper, 73 degrees Celsius. Plastic was 84 degrees Celsius. Glass was 66. Ceramic was 68. And metal was 59 degrees Celsius. See you back in 2 minutes. Okay guys, we're back. So it's been 6 minutes. The final temperature for styrofoam was 80 degrees Celsius. For paper was 65 degrees Celsius. Plastic, 75. Glass, 62. Ceramic, 60. And metal, 55. Now what you see range here. What I want you to do is the range is going to be the beginning temperature subtracted from the ending temperature, and that's going to tell you how much heat was released. So I want you to go through with your teacher and subtract the beginning temperature and ending temperature, and you will have your range for each of the materials, and then we'll come back. Okay, hopefully you guys were able to do some good math, right? Because science is math, math is science, right? All works together. So you will notice that styrofoam had the smallest range and metal had the largest range. Pause it and talk to your teacher about what this might mean about which is the best insulator of thermal energy. Which material trapped in or held in the most heat? Okay, so based on that information, you should have realized that on this test, right, just this particular test, there could be lots of different cups, lots of different materials, larger cups, smaller, but with these materials, our experience is that the styrofoam trapped in the most heat. So it held in the most heat. And the metal cup released the most heat. So that means that the water in here is still pretty hot compared to the water in here. So this was the best insulator. This is more of a conductor. It was the worst insulator. And actually, really, if I touch my finger on this, it's pretty hot. So it is really letting that heat out. I can feel it on the outside of the cup. So it is definitely not the best insulator. It is not trapping that heat in. So then you ask, well, Miss Guerra, that's weird because that's a metal cup. And I know people have things like Yetis and hydro flasks that they use and they spend a lot of money on to keep things either really, really hot or really, really cold, right? To trap that heat. So in this case, Mr. Guerra puts his coffee in here. It's a good insulator. This metal container, this Yeti, keeps his coffee really, really hot. It doesn't allow the heat to escape. That's because this is made differently than that one. This is made with lots of layers of metal and it's also vacuum sealed. So there's lots of layers of metal in here. This is also, so this is a very good container to keep my ice water cold. The metal, the layers of metal and the vacuum sealed inside of this does not allow heat to get in, right? So it keeps heat out. It is an insulator. So it can keep my water pretty cold by not allowing heat out, okay? If I wanted to put something really hot in here, it wouldn't allow heat to come out either, right? So it traps that heat. Both very good insulators. But why, Miss Guerra, so thinking about styrofoam and Yetis, why wouldn't Starbucks give everyone a Yeti instead of a styrofoam cup, right? Well, that's because this, thinking about money and expenses, right? This is the best container to use that is not going to be very, very expensive, or something like this, the paper, not going to be very expensive, and it is going to hold the heat in. Now, one reason a lot of places have chosen paper even over styrofoam, even though styrofoam is a better insulator, is because paper is better for the environment, right? You can recycle it. Styrofoam, not very good for the environment, right? So you have to think about physical properties of things, right? This is the better insulator of all of these materials, so I'm gonna put my hot cocoa in it, right? But companies like Starbucks, they have to think about, this is a pretty good insulator too, and it doesn't cost as much money as these other types of cups. It's also better for the environment. So that's a good way. But the best thing is, take your reusable cup to Starbucks, and that's an even better way to take care of your environment. All right, thanks guys. I hope you enjoyed this investigation on finding the best insulator of thermal energy. I enjoyed working with you, and I will talk to you soon. Bye.